Bismillah ar-Rahman ar-Rahim. Welcome all to this session. If you would like to, I'm open in يعني managing this session. Whether you want me to answer your questions or go over an exam, both are fine by me. So, if you would like to answer questions, then we should take raise your hand and wait for your turn, please. Okay, we'll give يعني equal opportunity for everyone to ask questions. So whichever you like, I can provide you with. Okay. So let me see. Any questions that you'd like to answer? Okay. So we have a question from Hind Al-Ghamdi. Go ahead, Hind. Ask your question.
I sent it in the chat.
So yeah, you can go ahead. Do you have any question? Oh, you wrote it in the chat?
Yes, thank you.
All right. So we have I need to copy this to my PDA. So okay. Actually, let me copy the whole question. All right. Drop. Okay. Oh, for me to be able to, so I'll put it here somewhere. Any other page? Okay, and then go to pictures. This is the question, right? Okay, so we have a circuit implemented using XNOR gates, and we would like to convert these to the minimum number of XOR gates. Okay, that's a good question. So first of all, you need to manipulate the bubbles and then see whether the circuit reduces to a smaller number of gates or not. So first of all, you can basically advance. See this bubble. Let me use a pointer. This bubble and this bubble. You can advance them here and here at the input, and they will basically cancel each other. Okay, cancel each other. All right, and then we can also advance this to here and here. Okay. So let me just write that. Okay, so this one, well, we have the bubble going here and here, so no more bubble here. This is already XOR. Okay, and then this one will cancel this one, and this one will cancel this one, so no more bubble here and no more bubble here and no more bubble here. Okay, in order to cancel this one, we need to add an inverter, right? And to add an inverter, we use XOR to implement that inverter by XORing with 1. Okay. However, this circuit is not what we call a minimum. It does not use a minimum number of XOR gates. Okay. And to see that, to see if your circuit can minimize or not, whenever the circuit has a fan-out branch that reconverges here, look, this one reconverges, then you'll have cancellation. You'll have cancellation. So here, in this case, for example, you can see here, this is what? This point here is B XORed with C, all right? And then you have it here, it is going to be A XORed with B XORed with C, right? And here, it is going to be B XORed with C XORed with D, all right? And then at this XOR gate, we will get rid of B and C, okay? And the only surviving literals are going to be A XORed with D, XORed with, that's it, XORed with nothing, okay? Because B or X or C will cancel each other, okay? Since you are XORing them together, they cancel each other. The answer is 0, so A XORed with D XORed with 0 is going to be A XORed with D. So now the circuit becomes what? Basically A XORed with D XORed with 1. So you have an XOR gate here in which you have A and D, and then you XOR the whole thing with 1. That's the solution. Okay, this is the same output as exactly the original function. Is it clear?
Yes, thank you.
دكتور بس لو سمحت
Yeah.
هالسؤال ما
سؤال؟
قال يستخدم minimum number of XOR gate فلازم أسوي لها decrease ولا أخليها نفسها؟
Yeah, usually here it didn't say. So basically, if it didn't say, then yeah, you're right. You have the option to minimize it or not. But it is always better to come up with the minimum number of XOR gates. Okay.
Can I add NAT بدال الكونفرتر اللي حطيت اللي هو الXOR في الأخير؟
You mean this one?
إيه أحط NAT بس بداله؟
No. Look, the question says only to input XOR. That's it. All right. So you cannot use inverters. No.
دكتور عندي سؤال.
Go ahead.
في الأسئلة اللي فيها الناند والنور لازم أحط إذا كان مثلا بسوي نوت أقدر أقول A بار ولا لازم إني أشبكها في ناند جيت يعني أشبك
It depends on the question itself. Okay. If the question says the variables and their complements are available for you to use, then you can use the complemented version of the variable without putting an inverter. However, if the question doesn't say that, then you have to use an inverter and convert that inverter to either NAND or NOR. Okay. So that's the so basically let me look for a question that probably does say that.
لأن في أسئلة يقول لك استعمل ناند نور أحولها إلى ناند أولي إمبلمنتيشن وشفتكم تستعملون أنتم A بار بدل لا تسوونها تشبكونها في 2 input ناند فكنت بس أتأكد إذا بتسأل أو not.
Yeah. For example, not here. This is a midterm, so it should contain, yeah. So basically here, assuming that all inputs are available, look, are available in what? In true and complement forms. So here you are free to use a complement or A. Okay, يعني it is ready for you. You don't have to use an inverter for A. Okay, in this question, you are free to use that. However, sometimes the question doesn't say this, so you shouldn't assume the availability of the true and complement form. So you must use an inverter to generate the inversion of the input variable. Okay, if this is not mentioned here, if this statement here is not mentioned, then you must generate the complement form of a variable in case you need it. I hope this is clear.
اي يعطيك العافيه شكرا.
Allah يعافيك. طيب. So we have, I think we have some other questions here in the chat.
معليش دكتور.
Yeah, go ahead.
في السؤال اللي سألته الأخت ليش شبكت مع الواحد الإكسور؟
لأنه في because there is an inversion at the end, remember? Okay, what is that? The original question, there was, if I may use the eraser, okay, I will use the eraser, okay, to show you that there was a bubble at the end, okay? Okay, this is an XNOR at the end, it's not an XOR. So in order to, because we use only XOR gates, in order to invert this output, okay, we remove the bubble, and then what do? We add an XOR gate, XORing this output with a 1. Of course, this bubble is no longer there. Okay, so this is an implementation of the inverter using XOR, because the question restricts you to use only 2 input XOR gates. You cannot use inverters or XNORs. Got it?
أي واضح يعطيك العافية.
يا شباب ترى half of the answer in the question itself. Read the question carefully, okay, and read any constraints in the question, and you'll be fine, okay? You'll be fine if you do that. طيب. Where is this? Okay. So we have a question here. Okay, so let me try to, you know, in the downloads probably. There is a question here. Okay, maybe I should also share this screen here. Okay, so there is a question here that says to represent the decimal number 256 in BCD requires how many bits? The question is requires how many bits? طبعا and to represent this the same decimal number in binary requires how many bits? So the question asked by your colleague here says, why isn't it 8-bit? Okay, because basically 256 or 256 is 2 to the power what? The power 8. Yeah, 2 to the power 8. And 2 to the power 8 in binary is 1 followed by how many zeros? 8 zeros. Okay, 8 zeros. So the total number of bits in the number in this 256 integer is 9 bits, not 8. Okay, this is why. All right, so we have another question about one of the previous, last term exam, which is a true or false, true or false. I think it's better to probably, yeah. Here, this is a true or false statements. Okay, we have the first one. If A and A is a Boolean variable, and F1 and F2 are arbitrary Boolean functions. Okay. So if A ANDed with F1 equals A ANDed with F2, then we can imply that F1 equals F2. This is a what, ya shabab? This is it true statement?
False.
This is a false.
No, it's not.
False statement. Why? Why is it false?
Because if A is 0, then the result will always be the same.
Right. So if A is 0, for example, because we told you that A is a Boolean variable, we didn't tell you that A is always 1. No. It's a Boolean. It can be 0, it can be 1. If A is 0, then no matter what the value of F1 and F2 are, the equation will hold, even if F1 does not equal F2. Okay, so this is a false statement. The same goes for the second one, because if A is now 1, because it's the controlling value for the OR, whereas 0 was the controlling value for the AND, okay, then this statement will be false. So the statement is false. However, here the statement is true. Why? Because you can XOR both sides with A, and A will cancel, and you get eventually F1 equals F2. All right. I think I should switch to the iPad and discuss this a little bit more. Okay, it's okay. So yeah. So we have here, we have A XORed with F1 equals A XORed with F2. What does this imply? We're looking for the implication of this. Does it is it compliant with the statement of number 3 or not? So basically, this is a Boolean equation. You can solve it. You can solve it basically by XORing both sides with A. Okay, XORing both sides with A will yield what? A XORed with A XORed with F1 equals A, again XORed with A XORed with F2. All right, and then these A's will cancel because the value is 0 here, and 0 XORed with anything is the same thing. Okay, so you get F1 equals F2, and this was the conclusion of the if statement in the question. F1, so the question says if this is the case, then F1 equals F2. So this is a true statement, true. Okay, so this is a true statement. Any question about this? Okay, so let's move on to the next one. Okay, the next one says if A XORed with F1 complement equals A complement XORed with F2 and the whole thing complement, then I can say, I can just use this implication sign, then F1 equals F2. Is this a true statement or not? Let's start with this and see whether it implies this or not. Okay, so starting with this statement here, I can say, well, the right hand side is what? Is what? It's basically you can cancel out the complements by the properties of XOR gate. Okay, so basically it is A XORed with F2, and the left hand side is basically the same, which is A. We don't need to manipulate it. I mean, XORed with F1 complement. So if you XOR both sides with A, you get F2 equals F1 complement, which contradicts with this. So this is a false statement. This is a false statement. Okay? Anyone is confused about this? Okay, let's move on to a different question. Probably you guys are so we have this question here. If you type the word COE on your keyboard, what is the binary sequence sent to the computer using 8-bit, okay, ASCII code, with the 8th most significant bit being an even parity bit? Note that the 7-bit ASCII code for A is hexadecimal 41. Hexadecimal 41. So basically, let me open up text editor here to just solve it. Texted it. New, and then share. So the question says that A is 41 in X, right? So it must be the case that C, let's say B is going to be what? 42. And C is going to be what? 43. And so on and so forth. So C, now we need to encode COE, right? So we have C, let's count. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. So it is basically 15, right? Is it 15? 15, I believe. Yeah, 15. So basically 41 plus 15 for 1H plus 15 in F, which is F here. So basically the answer is going to be 16, which is 51, yeah? 50, yeah? 0H, yeah, 50.
Yes,
so this is the O, isn't it? So if this F is H here. And what about E? It is A, B, C, D, E. 5, right? 4, 5. 4, 5, H. Now, this is the E. Now you need to represent this in binary so that you decide on the parity and then change this to hexadecimal. So the 4 is going to be 100 and then 0011. Okay, so we're assuming even parity. So the parity bit here is what?
is 1.
Yeah, 1. Excellent. Okay. What about the O here? It is 101 and then 000. Okay. So this is already even. So it is 0. And for the E, it is going to be what? 100 and then 0101. Okay. So we have 3 ones here. So we need one extra one. Okay, to make it even. So this is going to be C5, and this is 50. Okay, it didn't change, and this is C3. So the sequence that is going to be sent is C3 followed by 50 followed by C5. Okay, this is in hexadecimal. In binary you have it already. Any question about this?
How the O become 15? 50.
Count now. The A is 441, right?
Yes.
In ASCII, the letters are stored in a consecutive manner. A is 41, B is 42, and so on and so forth. So if you reach the O, it is going to be 15 letters after the A, right? 15 letters,
Yes.
15 codes after the A. So we add F to it, to 41 added with F to get 50. Okay.
Victor, 15 or 14?
Yeah, let's count it again. H, I, J, K, L, M, N, O. No, 15. 15. It is 15. Just make sure that you get the. So this is hexadecimal and this is hexadecimal. All of these are hexadecimals. Okay. I hope that you guys get it. Right, let me move. If there is no question about this, I'll move on to a different question.
Question, Doctor.
Fadal.
Do we include A when we count till O?
Yeah, A is 41. So you start with A being 1, B being 2. Well, like this, yeah. Okay? Just count, use your fingers, okay? A,
Okay.
B, use your finger. A, B, C, D, like this, okay? All right.
Doctor?
Right.
Doctor?
Yeah.
Doctor,
Mhm.
43 would be converted to 1100 001, and then
4-3 in hexadecimal, 4-3 in hexadecimal is 1000011. Yes. But then we added an even parity here. This is not an equality. I'm sorry, this is not an equality. So we can just say here after adding the parity bit, okay, it is like this, okay. And then this is not equal, okay. This is after adding the even parity bit, okay. Cool.
دكتور جدول الاسكي بيجينا في الاختبار؟
You don't need it. We told you in the question that A is for 1, right? So you can derive the rest of the letters. You are expected also to know how to convert between lowercase and uppercase letters. Okay, there is a relation. This is part of your knowledge of the ASCII code. Okay, it is required that you know this. Okay, so we have another question. Any other question about this? I see so many questions about the parity code. It's a confusing subject for the students. Okay, so this is a nice one, nice question, and it is basically a direct application of the conversion algorithm, basically from hexadecimal to decimal. And this basically, this formula here converts a hexadecimal number that is basically composed of the largest hexadecimal digit composed of 7 digits and convert it to binary. So basically, the formula that we use usually is basically 16 to the what? To the number of digits, which is 7 minus 1, right? 16 to the 7 minus 1. So basically, probably the. So what is the text pad? Text pad. So many windows open. Yeah. So if you want, I can say here, I will rephrase the question. Sum of 15 times 16 to the n, okay? And n goes from, yeah, you can say that here. N goes from 0 to 15, to 6, I'm sorry. So if you have this now, think about this number. F, okay? I'm sorry, it's like so many F's here, okay? But anyways, it's 7 F's, okay? Let me just put an underscore between them to make it clear. Probably I will also make the font larger. It is clear. Okay. So if you have this number here in hexadecimal, what is the decimal value of this number using the properties? Using the properties, is basically it equals 1 followed by how many zeros? 7 zeros in hexadecimal minus 1, right? And this can say, I can put an equality here, okay? Equality. So I'm representing the numbers here in hexadecimal now. Now I'm using this decimal, okay? I'll convert this to decimals, which is what 16 to the 7 minus 1, okay? So this equals the question wants it in a power of 2 format, okay? And you know that 16 is what? 2 to the 4, right? And then the whole thing to the 7. Okay, and then minus 1. So 4 times 7 is 2 to the 28 minus 1. So this is why we get 28 as an answer here. Got it? Okay. No question about this? Okay. Can we convert? This is a question. Can we convert OR gate to XOR? If it is possible, then how? So you want to convert an OR gate to XOR. Well, using only who asked it? Muhammad Mukli. Muhammad Mukli.
Hello.
So can you elaborate your question, please? Because it's not clear. So you want to use only OR gates to implement XOR, or you want to use only one OR gate to implement an XOR? Is this your question?
In one of the quizzes, there was a question how it can possible. Is it possible to use to describe a whole circuit using only AND and XOR gate? The answer was yes. How can, okay, we have AND, we can
معلش. Can you say it again? Can you say it again, please? Can you say the question again?
الكويستشن يقول انه الست هذه تقدر انها تسكرايب كل السيركت. كان
Okay.
واحدة من السيتس AND و XOR، فبالتالي انا احتاج اني انا اعرف الAND موجودة والانفرتر اقدر اكتب انفرتر using XOR، بس الOR
Yeah.
كيف اكتب XOR using AND
Okay.
OR using XOR.
لا, okay, your question, okay, for your question that you wrote, it is impossible. You cannot convert an OR gate only by itself to an XOR gate. Okay, you have to use other gates as well. Okay, but if you have an or let's say an AND with an XOR, okay, and you would like to implement out of these gates only, you would like to implement an OR gate, then you can do that. Because why? Because an AND plus XOR, you can convert it to what? NAND. And you know that NAND is universal, right? Universal gate. So you can implement any gate, any circuit actually using NAND. Okay, how can we implement an AND using AND and XOR? Basically, you have an AND, and then this should be followed. Maybe I should do it in my PDA. Okay. All right. So if you want to implement an AND using XOR, an AND and XOR, okay, so you can convert this using an AND gate, simple AND gate, and then an XOR gate with 1. So the whole thing here is a universal gate because it is equivalent to an AND gate. Okay, so to implement, for example, you want to implement A or B, مثلا. Okay, for example, how do you implement? How do you using NAND? Using NAND, so you want to implement this using NAND? Okay, how do you do it? Basically by inverting
A and B.
the inputs and then taking the complement of the inputs as well. Okay, so if you do this, then this is equivalent to, and this is A complement and then B complement. So if you want to use this set, then this is going to be what? this is going to be A XORed with 1. This gives you A complement. And then B XORed with 1. This gives you B complement. And then you AND the 2. And then you XOR that with a 1. This will give you A or B. Okay? All right. And don't worry about this, guys. This is like in the fringe department. I mean, it's not. We are going to ask you questions in the exam about NANDs and NORs and XORs. Okay, we're not going to ask you about other universal gates that are there. The universal gates that we have studied are 3 basically universal sets. Okay, the NAND is universal. The NOR is universal, and the set of AND, OR, and NOT are universal. Okay? XOR and XNOR by themselves are not universal. Okay. Let's see this question. Right. So this is a question about from Rida. Share it. Rida, can you please ask your question here because it's not clear to me. Would you like me to go over the answer here?
إيه دكتور، سؤالي هل أقدر أحل هذا على أنه من تيرمز، أجيب المن تيرمز أحط مثلا A B داش وداش داش حق السي والدي، وأحط بعدين حق الحد الثاني داش داش سي كومبلمنت دي، وأجيب جميع الاحتمالات، ولا غلط كذا؟
No, actually, midterms are just by looking at this question, there is a loophole in the question that allows you to express G in midterms form, sum of midterms form, and yet your answer will be correct because the question doesn't say express G in a product of sums form with minimum number of letters. If it says that, then no, your answer will not be correct. Okay? You get
السلام
it?
عليكم.
اوكي، يعني سؤالي حل يكون صح اذا انا ما حدد هنا.
If it doesn't specify, for example, the minimum number of letters, if there is a specification of the minimum, because sum of midterms is basically a sum of product as well. Okay? But the question here, by the way, the question here is express G in product of sums, not in, so it should be max terms, not min terms. Okay, your answer should be in max terms. Okay.
طيب دكتور، سؤال ثاني.
دكتور نفس السؤال هذا أنا عندي سؤال إذا قبل ما نروح سؤال ثاني يعني.
طيب go ahead ask.
هل أقدر أحلها بالدول؟ أحول الآند إلى أور وخلاص نحل.
عندك شوف or تحت هنا or you can use the duality to solve this problem. So yes, by all means you can take the dual and then convert it to sum of products and then take the dual back and then it will be in product of sums. Okay?
ما فهمت ليش آخذ الدول باك.
لأنه dual is not the same as the original function. The dual of f is not necessary, does not necessarily equal to f. Okay, so if you take the dual is like a transformation يعني. فهمت علي؟ يعني like the integral transforms, for example. يعني the Laplace transform مثلا. You take the Laplace transform and then you manipulate for example you start with an ODE, for example, a differential equation, and then you take Laplace transform, and then you solve it algebraically, and then you go back by taking the inverse Laplace transform. صح? It is similar here. It's similar. So you take the dual, and then manipulate the function, and then take the dual back. So it has to be the same function that you because the dual of a function is not necessarily the same or does not necessarily equal to the function.
جميل، يعطيك العافية.
الله يعافيك. طيب. Okay, so we have a question here from, I believe, yeah. So this is the question here. I'm going to, oh, okay. That is really a serious question, okay? Let's try it together, okay? And see what happens. So I'm going to copy it to my iPad, and then, so I'm going to copy the expression, and then let's solve together. A, B, ORed with A complement C, ORed with, there is D complement, B complement C, and then the whole thing complement. Oh, okay. This is a proof. So we need to prove that this equals AB ORed with A complement C, or ORed with C complement D. Okay. So basically, we share my iPad. You can start with whichever side that you like, but I think it's easier for me to start with the left-hand side, okay? So you start with the left-hand side. So we have to prove this, okay? Prove this. Left-hand side is going to be equal to, first of all, apply De Morgan's law, okay? AB or with A complement C, and then what do you have here? D ended with B or C complement, yeah? And this is by the Morgan's law, okay? And then this equals, again, AB, ORed with A complement C, or ORed with BD, ORed with C complement D. Okay, so you can see that we already, so there is C complement D and C complement D in the right hand side, comparing the right hand side. What is missing and what is extra here? Okay, we have A complement C, and we have AB and AB. Okay, so it must be that BD is somewhat redundant. Okay, so it probably it's a consensus of two terms. Okay. If we, for example, let's see. So let's see. These two terms, the consensus here is going to be BC. And these two have a consensus of A complement D.
Oh, Doctor.
Yeah.
We can use BC to remove BD with the C bar D consensus once again, right?
Yeah. Excellent. Yeah, using minimization. Not minimization, actually.
Consensus as well.
Yeah. So basically, are these all the consensus terms available? Okay, they are all. Okay, so AB, I'm going to add BC now. AB ORed with A complement C, ORed with BD, ORed with C complement D, and then ORed with BC, okay? All right. So did I do a mistake in the complements or something? Or we can,
No, I think it's right.
Okay, so now this is by consensus, yeah? Okay, now this is going to be AB, ORed with A complement C. Okay, now we take B as a common factor by distributive law, C or D, right? And then, no, actually.
No, you don't need to, Doctor.
Doctor, you can take
BC and C bar D.
Yeah, so basically B and C and C bar. B, yeah, this will give you DB, okay? So basically, this tells you that the consensus of these two terms here, okay, tells you that what is the consensus here is BD, and it is basically available here, okay, available here. So basically, this can be dropped by consensus theorem, okay, because it is basically what redundant by consensus theorem, okay. So we can drop it, and then again, BC is the consensus of AB and A complement C, so we can also again drop it, okay. So we can say C complement D, and this is by consensus again, okay, by consensus, okay. So basically consensus is taken between this and this, and between this and this, okay. So, and this equals right hand side, right? So this is the end of the proof. Okay. Any question about it? Okay, we have another question from Reva here. Okay. All right. So this is used to be a quiz question in my section. So the question says here, given the following Boolean equation is true. Okay, given the following Boolean equation is true, I'm going to copy it to my iPad and then solve it together there. Okay, so it is A or XORed with B, XORed with A complement, A C complement equals B XORed with C. We want to imply the value imply, this is the question, imply the value of A ORed with C complement, okay, using, of course, by solving this equation, okay, by solving this equation. So let me share my screen on the iPad again. So basically what you can do here, you can get rid of the B, right? B, you can XOR both sides with B, and then it will be removed, right? So you are left with A XORed with AC complement equals C, right? Equals C. Now, you can convert this to the basically, there is a property in the actually in the XOR gate, okay? But we didn't teach it to you, okay? We didn't teach it to you, in which you can take common factors, okay? Common factors. So A, you can take A outside here, and then it will be A1 ORed with, XORed with C complement, okay? And that equals C, all right? And then this is, but you don't have to do that. You don't have to do it this way, of course. You can, what can you do? You can convert this to algebraic manipulation, okay? Like, for example, A complement ANDed with A C complement, ORed with A ANDed with A C complement, and then complement, okay? And that equals C, right? This will go away, and this will be what? This will be A ANDed with A complement ORed with C, right? And that equals C, right? So this is one way to do it, and this is another way to do it, okay? So basically, if we take this root here, we will have what A 1 XORed with C complement is C, right? And that is equal to C. When will this equation be true?
If A is equal to 1.
Yeah, so basically, no. Actually, the thing that is important here is A, basically. Okay, A is the controlling factor. C is a free variable. A, when A is 0, this equation will not be correct. So A must be 1. Okay, A must be 1. Okay, and if A is 1, okay, then by basically in order for C to be basically actually you don't need to continue here. You don't need to know the value of C, because what are we implying? We are implying A ORed with C complement, right? Wait, was it this? Yeah, implied. So if you want to imply this, then A is 1. So 1 ORed with C complement is going to be 1, regardless of the value of C. Okay, so this is the answer to this question. Any question here? Yes, question. Reda.
لا بس يعطيك العافية دكتور، وضحت.
Oh, no question. Okay. Fine. Okay, let's move on to a different question here. Okay, so we have okay, this is a similar question to one of the questions that were asked. Okay, so given the following circuit diagram with XOR gates, redraw using only XOR gates and the minimum number of inverters. Okay, you may insert inverter only when necessary. Yes. Oh, you cannot see. Okay.
لا، عندي سؤال بخصوص هذا النوعية من الأسئلة. أحيانا يروح يبسط لي الدائرة بدون ما يقولوا إنه بسط لي دائرة، وأحيانا لا ما يبسطوها. فإذا ما قال لي بسطها وأنا بسطها، هل يعتبر جواب خطأ؟
Actually, here it says redraw the above circuit using the only XOR gates and minimal number of inverters. So yeah, maybe it needs to say minimize the number of XORs, okay, or the number of XOR gates with using minimum number of XOR gates. That is probably required in order to account or deduct points if that is not mentioned. Okay, so this is the question here, and I think this question was there before, صح? I think it's exact same question, but it's drawn in a different way. Okay, but you know that B and C are going to disappear because of the reconverging fanouts here. B and C are going to disappear. So mainly you'll have a simpler circuit. Okay, you'll have a simpler circuit. So let's do this one. Let's do this one. So I'm going to share my iPad and redraw it for you guys. And so we have, and I advise you, by the way, I advise you to always minimize the number of gates. Okay, even if it's not mentioned. Okay, even if it's not mentioned, just to be in the safe side. Right. So this is A, B, C, and D. All right. So we would like to convert this to XOR. Okay, to XOR. So first of all, we can take this bubble here, this one, and forward it to both branches. Okay. So we'll have. We will get rid, let me use a different color. Get rid of this bubble, and then we'll have a bubble here and a bubble here, right? And these two bubbles, this one and this one, will cancel each other, and this one will cancel each other as well. So we will get rid of this and this, also this and this. So we wind up with 3 XOR gates so far. Okay, and then for this one, the question says you are free to use inverters. So I'm going to remove this and then use an inverter instead. Okay. Right. So this is without minimizing the number of XOR gates. Now, using Boolean algebra or algebraic manipulations of XOR, we can simplify this. This is B XOR C to both fan-out branches. And then this is A XOR with B XOR with C. And then this is D XOR with B XORed with C, right? So the BC will cancel out, and you'll have A XORed with D, right? So again, this is going to be A XORed with D, and then we have a simple inverter. So this is your
دكتور
A.
لو
Yeah.
أنا وقفت عند اللي فوق خلاص ما سويتها اللي تحت ما وصلت لتحت يعتبر جوابي صحيح بما أنهم ما قالوا لي minimize the number of gate.
Again, I told you just to be in the safe side, minimize them. Okay, minimize them. You have nothing to lose unless you don't know how to do that. If you don't know, ask question. Okay, this is the time to ask question.
Okay.
Do you know how to do it?
Yes, I know.
Okay, great. You can, by the way, just prioritize your answering the questions. Start with the easy ones, and then go back to the ones that require more work. Okay. Okay, so 7 by 4. Can we solve this problem with dual? Okay, yes. All right, and we have, yeah, we went through this question. We have Boolean
دكتور أنا
algebra
عندي
here.
سؤال بس الله يعافيك.
اي تفضل.
الآن إحنا عندنا ستاندرد فورم وعندنا كانونيكال فورم صح ولا؟
Yes.
أي
Correct.
واحدة فيهم اليونيك؟
Both are unique. Minimal.
Both are
I'm talking about minimal standard form and canonical form. Canonical cannot be minimal, of course.
إيش المقصود بالمينيمال؟
It can be minimal, but it's not necessarily minimal. Okay.
لأنه في
I mean,
أحد
minimal means minimum number of letters.
فكلهم يمكن يصيرون يونيك.
They are actually so sum of products, for example, sum of products. It is actually not unique if you don't specify that it is minimal. Okay, but if you say minimal sum of product or sum of product with minimum number of letters, then it is unique. Okay, it is unique, of course, modulo the order of the letters and the products. يعني ممكن تبدأ you can start with the first product and then the second and then the third, for example, or you can shuffle them. So we don't care about the order here. Okay, we're saying to you that it is going to be minimal without regarding the order. Okay.
لأنه عندي هنا سؤال يقول the canonical form and the standard form are unique for each function. True ولا false؟
The canonical form and standard form
are unique for each function. True or false?
طيب. For canonical functions, okay, it is unique. But for standard form, if you don't specify that it is minimal, then it is not true. لأنه this is simple. يعني I can convince you very easily. يعني for example, if you have A, can you see my? Am I sharing my iPad right now? Yeah, AB, for example, this is F. AB or CD. This is minimal. Okay, this is minimal sum of product form. Okay, now this is unique. However, I can always say this is A, B, all with C, D, D, using idempotency property, صح?
Sorry.
Yeah. And it's still this is not canonical form, but this is a non-minimal standard form. Okay. Also, I can say, well, this is A, B, okay, or with C, D, or with a complement. Isn't it? Yeah. This is it. Again. It's exactly the same, equivalent to this, but it is a different one because it lacks minimality. I hope this is clear. All right. So we have Abdulaziz Al-Hakami asked a question about we can go through it really quickly about the Boolean algebra here. Okay, Boolean algebra. So basically, you have this long function, and we would like to minimize the number of literals. Okay. So basically, here it starts with A, taking A as a common factor using distributive law. So A is existing here and here and here. So B or C or D. All right, and then we have B, C complement, D complement, B complement, C complement, D complement. Okay, right. So basically, this is what, by the way. Why, okay, I see why you are asking this question probably. How did we get rid of B or C or D? صح يا عبد العزيز؟
صحيح دكتور.
Yeah, the reason is by simplification, because this is your X and this is your X complement by De Morgan's law. Okay, so by De Morgan's law, if you take the complement of this, it will be this. So this is your X and this is your X complement. So this will disappear by simplification rule. Okay. And then we have here, okay, so this is again by simplification. So we have here, okay, A with A complement D, and this is by absorption. Is it clear, Abdulaziz? No?
About the first part, BCD, I didn't understand how it vanished.
Okay. Let me share my iPad again. So it is what? AB or AC or AD B complement, C complement, D complement, with A complement, D complement. Okay, so the first step is to use distributive law to take A out of the first three expression or terms. Okay, so using distributive law, let's say B or C or D. Is so far so good, Abdulaziz?
Yes.
Do you have a problem with distributive law, Abdulaziz?
No, my problem is how did BCD
disappear?
Yes.
Right. Okay. So now this is by distributive law. I'm not going to write the justifications, but you are required to write justifications. Okay. So this is what? E. And then using the Morgan's law, this is what? B complement, C complement, D complement. Complement, right? I don't need the... Isn't it, Abdulaziz, by De Morgan's law?
Yes, doctor.
And then B complement, C complement, D complement. Formed with A complement, D complement. Yeah? So this is your X, and this is your X complement. So it is as if you are ANDing A with X complement, and then you are ORing with X. The simplification rule, what does it say?
Yeah, it will be A plus X.
Yeah, A plus X. So X complement, which is this, it will disappear. Huh?
Yes. I get it now.
Okay.
Thank you.
Sure. I have here Rashid. Okay. Oh, okay. This is a nice question. So, yeah, so basically we would like to draw the logic diagram for the 4-bit even parity checker that receives, the question is not complete, but anyways, we we want to generate an even parity checker that receives a 4-bit message ABCD along with the parity bit, okay? Along with the parity bit. So basically, even parity means that you need to use what? Odd function, and odd function means XOR gates, okay? So what do you need to do is basically XOR the whole thing, like this. So you need to XOR A with B and C with D, and then XOR the result, and then XOR that with the parity bit to get the error signal. So the error will be 1 if there is an error. Otherwise, error will be 0. So why is this correct? Because this will generate, this up to here will generate the even parity for A, B, C, D as perceived by the receiver or the parity checker. So now the receiver has a calculated parity bit that he will compare with the received parity bit, okay, using the XOR gate. And you know that the XOR gate will produce a 1 whenever whenever its two inputs are different. And this is what we need. So if these two inputs are different, then we need the error to be 1. Is it clear? Rashid, are you convinced about this? Okay, I think Rashid is not here.
Doctor, what about if it's odd parity?
If it is odd, then use what we call XNOR. That's it. Even parity XOR and odd parity XNOR. As simple as that. Okay? But if you want to use the XNOR, you place the bubble at the end. You use XOR and then place the bubble at the end. All right? You don't need to use XNOR at every step. Okay? طيب
دكتور عندي سؤال.
Yeah.
إذا كانت عندي اكسبريشن ما كنت عارف إذا هي ستاندرد فورم ولا لا، يمديني أشوف الليفلز أوف امبلمنتيشن، وإذا كانت أكثر من 2 فهي مو ستاندرد فورم. صح الكلام ولا؟
Yes, basically 2-level implementation is standard form, and multi-level more than 2 it is non-standard form.
جميل، يعطيك العافية.
Yeah. So we have a question here from Ali, but he didn't say who. Okay, it's a truth table here. Consider the following: express F algebraically as a product of max terms. Okay, so F is given in the truth table, and then we would like to express it algebraically as a product of max terms. This is, come on, guys, this is an application. It's a direct application of the material. There is nothing here to really, it's easy, okay? But the answer here is really not correct. If this is correct, then the answer is not correct. Because in the answer, A or B or C corresponds to max term number 0. So F at 0 should be 0. Okay? I don't know what is wrong here, but do we have Ali who asked the question? Ali, are you here? Let's move on. There is a problem in the question here. I don't know why. Okay. I hope that you see the problem of this. So there is a question here that is not complete by A. It says here draw a logic circuit, but that's not complete, so I'll not show it. Also by Rida, okay. Okay. I don't know what's that supposed to mean. Okay, so this is a question about implement the given circuit using NAND only. But the student who sent the question did not send the question, they sent the answer actually, okay? This is the answer, not the question, okay? So if you want me to solve it, you should have sent the question. طيب, for the benefit of everyone, okay, I'm going to solve a similar question to this in old exams, okay? I think one of you have asked me for term 212 exam. It is available in my Blackboard, and this is it basically. So yeah, this is basically conversion to.
Doctor, I have sent that question.
You sent this question. Okay, let me share.
The question.
Yeah, but you sent the answer, not the question.
Now I have sent that question.
Okay. So let's consider this question instead. Okay, if you understand this, then you will understand that. Okay, so we want to convert this now. Notice that in the question, the true and complement forms of the inputs are available to you, so you can use a complement without using an inverter. Okay, so I'm going to convert this to NORs only. Okay, so you start with the OR gates and put bubbles in front of them, and then cancel these bubbles to maintain the functionality of the circuit. Okay, now this one also, we need a bubble here, and then another inverter, which should be a NOR gate. NOR gate, right? Okay, so this one is still pending. It's not converted completely, so we need a bubble here and a complement here. Okay, also notice that this one has a complement here. Okay, this one has a complement on it. So if we want to convert now this AND gate, we want to convert it to NOR. Okay, so what do? We put bubble in its inputs and then cancel them. So this becomes F. So F complement is F, and this becomes G complement. So this is basically the conversion here. If you want to use inverters in your answer rather than doing this using NOR, then you must show the implementation of an inverter using NOR. Okay, you say here يعني على جنب شباب. Okay, here this is X, this is X complement, and this is equivalent to X complement. If you do this, then no need for this NOR, and you can say, well, this is going to be just an inverter. Okay, so I hope that this is clear, Shabab. Now you need to redraw it using NORs. Okay, E complement, and this is C and D, and this is A and D. And then we have here final NOR and an inverter. Okay, and finally we have the final NOR gate. And this is F, and this is the complement. Okay?
معلش دكتور.
Yeah.
عند الاف والجي الببلز.
Yeah.
حطينا ببلز تمام. هل ممكن احط قدام بدل ما اخليهم كومبلمنت احط انفرتر؟
Again, I'm saying to you that it is mentioned here that the complement and the true form of the variables are ready for you, available to you. You can use it without using inverter. If this is not given to you, if this is not in the question, then you must use inverters. You must use inverters or NOR if you are not giving this. Okay? If you give this, then you can use inverters. Got it?
واضح. يعطيك العافية.
Yeah. الله يعافيك. Okay, so this is about this question. Let me see if we missed something here. Okay, let's no, this is not part of the material. Okay, and this is not part of the material. So basically, standard for canonical and standard forms. I don't think that. I think it's an easy subject. You just need to be careful, very careful. Okay. Yeah. Okay, so I'm going to so given the following implementation of F. This is the last question that we received here. Given the following implementation of F, assume the delay is on the gate. So this is a question about delay, okay? Delay. So here, if we use the annotation, and gate is 2. So here we have 2, right?
Doctor,
Yeah.
that's the circuit that they want to convert it to only NAND gates.
Oh, you don't want the delay, yani?
Yes.
You want to convert it to NAND gates, huh?
Yes, yes.
Right. Okay, so basically what I can do here is I will transform this file to my iPad. Close the annotations. Get iPad, and then stop sharing. What is this question? Okay. Okay, so here is the okay. Okay, so we would like to convert this to NAND only, okay? We'd like to convert this circuit to NAND only implementation. First of all, you start with the AND gates by putting a bubble in front of them, okay? I don't know why it became blurry. Okay, and then cancel this bubble, of course. This one with a bubble here and a bubble there, okay? And then this one, we have a bubble here, but we have an inverter here because, again, this is already converted. Okay, we don't want to put a bubble before it because this may change the gate. Now, for this OR gate, we can move this inverter, we can move it ahead to be a bubble at input. So I'll delete it and put it in here, okay? And then put a bubble here, and let us assume that the inputs are not available. The complement of the inputs are not available to you. So you need C complement here. So C complement can be obtained by an inverter, okay? Obtained by an inverter. With this, you need to show how to implement an inverter using NAND, and then you are all set to this is X complement, this is X complement. If you show this, then you can use inverters. What did I do? Okay. All right, so redrawing this again. Mm, And then we have one here as well with an inverter. And then here we have A and B. So A and we have C here, in which we use an inverter. And finally, we have D and E untouched. Okay, this is your F. Clear?
Yes.
Okay.
Thank you.
All right. I think we should. Okay.
دكتور
Yeah. Let's take two more questions and then call it a night. Okay? Because you guys need to sleep as well, right? The exam is tomorrow. Huh? Go ahead, Nask. Yeah.
السؤال الصورة اللي صورتها قبل آخر سؤال اللي هو قاعد أحاول أحل الاسكي كود اللي هو شرحته في البداية. إذا ممكن تفتح الصورة أوريك.
This one. Yeah. This one.
يب. الحين أنا مسكت السي والأو والإي.
Yeah.
تمام. حطيت ال7 بت، حولت ال 43 ل 7 بت والأو والإي.
Okay. All right, I see what you do. But let me ask your colleagues. Anyone can see the problem that who's talking here? Is it Reva? So anyone can see the problem that Reva made, the mistake that he made? Shabab, this is a good exercise for you. Reva, can you see your problem, your own problem?
حاول.
Okay, when we say A is 4-1, is it in decimal or what?
When we say what, دكتور؟
Hexadecimal. It's not decimal. Okay? So you're saying I is 49, and then J, which is the next letter, is 50. You're jumping about 6 letters, 6 codes.
So it should be what?
After I is 4A, not 50. Okay? You see your problem here?
I is for 8.
No. J, I is correct. I is correct. Okay, for
الجي كم قيمته المفروض؟
الجي بتكون 4A not 50.
الهكساديسمال.
Hexadecimal, you're counting in hexadecimal, صح?
Yes.
Okay, let's take the last question. Anyone has a verbal question, Shabab? It's easier. Okay, I think we have had enough for tonight. Thank you all for coming to this help session. Yeah, I wish you all the success and good scores in the exam, inshallah. Okay, thank you.
اوكي شباب، بس ما عليكم امر، بفتح اللي هو باركود. اذا ما عليكم امر ابغى بس تسوون سكان حق الباركود عشان اللي هو تقيمون السيشن. اذا ما عليكم امر.
ابشر ما طلبت شيء.
يعطيك العافية دكتور علي سويان.
الله يعافيكم، حياكم الله. Muhammad, you may stop recording. There's no need for the recording to be that long. Okay.
اوكي ان شاء الله دكتور.